And next we're going to look at multiplication property of exponents. So looking at the table, our first row says 2 to the first times 2 to the second. So that means we have 1 2 times 2 2's, and we get 2 to the third. There's 3 2's. In the second one, we have 2 to the second times 2 to the third. So we have 2 times 2 times 2 times 2 times 2. And if you count up your 2's, we have 5 of them, so that's 2 to the fifth. Our next row, so we have 2 to the fourth, so 4 2's times 5 2's. If you count up, there are 9 2's, so that's 2 to the ninth. And finally, 2 to the sixth, so 6 2's. Whoops, there we go. Times 7 2's. If you count them up, we have 13 2's, which is 2 to the 13th. So hopefully you start to see a pattern here. So the rule for multiplying powers with the same base is that a to the m times a to the n equals a to the m plus n. And you notice that in our table. When we had 2 to the second times 2 to the third, we got 2 to the fifth. We kept the base of 2 and then added 2 plus 3 is 5. At the two examples down below, here we have 5 to the third times 5 to the fourth. Keep the 5 and add the exponents. 3 plus 4 is 7. Same thing applies with negative exponents. So here we have x to the negative fifth times x to the negative 2. Add your exponents, you get x to the negative 7, but if you recall from negative exponents, you can't leave your answer like that. Your final answer is 1 over x to the positive 7. All right, let's look at some examples of multiplying with powers. So number 1, 7 to the third times 7 to the second. Keep your base of 7, and then 3 plus 2 is 5. Number 2, 6 to the negative 1 times 6 to the fifth times 6 to the negative 7. So again, keep our base of 6 and add your exponents. So we have negative 1 plus 5 plus negative 7. We get 6 to negative 3. But I cannot leave my answer like that, so I will rewrite it as 1 over 6 to the third. And number 3, again, keep our base of 3, add your exponents. 5 plus negative 2 plus 4 is 7. And if I put that in my calculator, 3 to the 7th would be 2,187. Okay, multiplying powers in an algebraic expression. So in these examples, we're going to simplify, and the general rule tells us to multiply the coefficients, keep the bases, add the exponents. So in number 4, 2x to the fifth times 5x to the third. I'm going to multiply 2 times 5 and get 10. And then I'm going to, with my x's, keep that x and add my exponents. 5 plus 3 is 8. So I get 10x to the eighth. In number 5, we can multiply 4 times 6 is 24. I'm going to combine my m's. So I have m to the first, m to the second, so m to the third. Then I'll combine my n's, n to the negative 1 and n to the 7th, which will give me n to the 6th. And finally, number 6, I can take 2 times 1, so there's a 1 there, times 9 is 18. With my x's, I have x to the fifth, x to the third, and x to the fourth. So that is x to the 12th. And with my y's, I have y to the 6th, y to the negative 2, y to the 3rd. So that is y to the 7th. All right, now go ahead and try the multiplication property of exponents practice worksheet.